Hi, my name is Suttisak Soralump. I will give you an information about the landslide that happened uh, all around the world, uh, especially the situation nowadays. The landslide seem to be increasing in number of the frequency of the occurrence. Let me share the screen of my PowerPoint presentation, which is this one. Okay. My name is Suttisak Soralump again. I'm teaching in Civil Engineering Department, Suttisak University. My background is a geotechnical engineer. We're going to talk about the landslide management. These are the outlines or the topic that we're going to discuss in this lecture. First, we're going to discuss about the type of landslide, the case histories, factors affecting landslide, mechanism of rainfall trigger landslide. There are other trigger situation, for example, like earthquake. I'm going to touch a little bit on that as well. And then we're going to concentrate on the landslide risk management. Other than that, I may have some information to add on, but we will concentrate on the first five outlines. Okay, and then for the second part, okay, will be the tools for the landslide mitigation. We're going to also discuss about that. Landslide maps, indirect warning. How can we do the warning for the landslide evacuation? Indirect warning or direct warning. And last one is the dynamic landslide hazard map. Okay, so these are the topics that we're going to discuss in this lecture. But let's start with an overall or overview of the natural disaster that record in 1950 to 2006. So let's say that it's about like 50 years time period. You can see that there is a trend of increasing of the number of the disaster that occur, number of events. Um, However, if you look closely, the color that show you in green, blue, and yellow is all the hazards that related with the weather. It might be climate change or climate changing or whatever. But anyway, these are the things that we can see that the weather related hazard is actually increasing. Those three are windstorm, okay, which is in green, flood, we have more flood, we have more yellow color, which is the temperature extreme, very cold or very hot, something like that. Um, but the event or the hazard that has the uniform distributed is an earthquake. Okay, earthquake is seem to be increasing in number of events, but actually, naturally, the by the information, the frequency of occurrence is the same. It's in the normal. It's in the uniform distribution. Let's concentrate in landslide. This is the location of the landslide that occurred only in 2003, only that year. Okay, the total number of 194, yeah, 94 cases, and 81% of these landslides caused by heavy heavy rainfall. Okay, um, you can see that the susceptibility index, showing the levels of the susceptibility of the landslide that occur. There are also some information not only in 2003 landslide but also 2007, which is also has a lot of landslide that occur. You can see that the concentration of the events concentrate in the Southeast Asia, okay, southern part of Japan, and also the middle part of Japan, but very heavy in China and the border between China and Nepal, okay, India, some this area, okay. Also, landslide also occur, okay, in the America continental, okay, North America, Central, something like that. But if you look closely, you can notice that if you learn about the plate tectonics, you can see that the landslide lie along the plate boundaries, because that is where the the crust, the earth crust move and crash to each other. So that's where we have a steep slope, where we have the rock and soil that is decomposed very fast because of the geothermal underneath the ground that leak out and then causing the deterioration of the rock or soil more than the other area. Okay, so that's why there is some uh, rough correlation between the landslide location and also the uh, uh, plate boundaries location. Um, Actually, the researcher, landslide researcher, give many definition, many types of the landslide. But in practical, I would like to just conclude that the landslide has only two big subgroups. The first one is what we call the slope failure or the landslide with some limited area, and that caused by a man-made. Okay, by cutting the slope, by disturb the slope, by building, the construction load over the slope, and cause the landslide to occur. This is an example. Like this house built behind the house here is a hill, a small hill, but the owner cut the toe of the slope. Okay. During the cutting, there is no failure, okay, because the soil is still dry. But during the heavy rainfall, okay, this unstable slope slide down. Also, the same thing. This road cut through the uh, landslide susceptible area, which has a rock or geological structure that is favorable to the sliding. So that's why when after cutting for some seasons, not long, and then heavy rainfall come and everything slide out. You can also see some example here of the construction of the road cutting without any reinforcing for the slope here or the cut slope here. And then we can expect the future failure that would occur. And also if we can also put ourselves in risk situation. For example, we cut the slope and then we build the house, but there is no protection, no slope protection at all, and that can cause the sliding later on, okay, especially when heavy rainfall comes. So this kind of landslide or slope failure is basically from the man-made, or human-made, from the development of the residential area or infrastructure into the sensitive area. This is one of the example, okay, of the building, okay, that built near the slope hill, and this construction have done by cutting the slope, because the original ground is in the slope area and it's not suitable for the housing, or this one is a school building, okay, so that's why they cut the slope. Okay, they did do some benching is mean that you cut as a step, okay, but that may be not enough. During the heavy rainfall, this slope move and finally you can see this, okay, the mass of the soil pushed this building and finally the whole building collapsed. Okay. This is another example, okay, where this is the hotel that built, okay, on the near the top of the mountain. This is the mountain ridge, which is built as a road, and then this one is located nearby the rich. And then after 20 years of service, this hotel, one day heavy rainfall come and this hotel slowly moving down. Okay, when we look at uh, the top view, yeah, of this situation, this is the hotel that already removed. Okay, part of it. You can see the whole area here slide down, and the reason is because this is the area that they release the water, the surface water. It will collect it somewhere around here and then discharge or release here. Okay, but they just release it directly into the original soil. Yeah? So that's why there is a big erosion here, and then this erosion causing the movement of the slope, and later on causing the movement of the buildings construction there. If you're interested, you can go to this, yeah, YouTube. I will introduce you later on, yeah, about the YouTube channel that I also have, and then you can get some information about the landslide over there. So how can we mitigate, or how can we improve and prevent the slope failure from the man-made? There's two things. We need to improve engineering standard for the cut slope. The standard need to be in several levels, depending on the risk of the human life, loss of human life. Okay, if it's high risk, we should put it in a very high standard, or otherwise, okay, maybe the following standard will be according to the risk of the loss of human life later on. Okay, and you cannot have only the engineering standard, but you need a law enforcement, a proper law enforcement, uh, in order to make the people to follow the standard. Okay, this is very sensitive issue. It's not easy. You just not have the standard and then you just enforce, okay, to the people, because there are several factors, okay, that you also need to consider. For example, if you work in developing country, of course, the economics, yeah, is one thing that you need to consider first. Okay, and then also if the engineering standard is too high, you also need to look back at what is the qualification of the engineer in that country or in that area. Okay, is there going to be enough engineer, okay, to help doing the slope stabilization or not? Something like that. These are the things that is complicated and not easy. Okay, I think it's more complicated than engineering itself. Okay. The second type of the landslide is debris flow. You can say that this is the according to the it's occur because of the natural events from the excessive rainfall. Okay, so when you have a lot of water from the rainfall pouring down into the slope, okay, finally the slope will got erosion, and then the slope start to slide, mix with the eroded soil, mix with the rock, tree, everything gonna slide down. We are called, the lump of those material as a debris, and it flow like a water because it has a lot of water that add into the material because of the heavy rainfall. Okay, and this kind of landslide, or we call the debris flow landslide, can affect it in the very large area, okay, and very dangerous. Okay, these are the example of how the mountain looks after the debris fall occur. Okay, heavy rainfall occur. Okay, many areas slide down like this. Okay, and then the accumulation of the debris accumulate and then flow down the slope. This is another example. Okay, in Krabi province in Thailand in 2011, you can see that This is the mountain. I took this photo when I was in the airplane, and then I look at this. Actually, I was going there, going to this landslide location, and then you can see the scar of the landslide, and also the erosion that bring all the debris down, okay, to this uh, uh, to this area. Okay, this area is a toe of the mountain, has 3 villages was located over there, and then it was destroyed by the debris. Let me show you the debris, that how it looks like. This is how it looks like. This is the rock that slide down from the mountain, and then of course, if you look at this massive rock, it's almost no way that you can build any structure to resist this kind of momentum from this rock. Okay, so all 3 villages in this area was destroyed, okay, because of heavy rainfall and also debris flows. And then one time I decided to walk over um, into the mountain where the scar, you have seen the scar on the mountain. So we walked up, and it took about 3 hours to walk up into the slope. And this is what it's like. Okay, the scar that you have seen in the slope in the previous photo is caused because of the erosion. Okay, because heavy, large amount of water pour down and then flow down the slope. You can see that, imagine that during the debris flow, the height of the water or the flowing material may be more than about 5 meters, okay, or more than that, okay, and then the width of this one is about 20-30 meters, and then the mass of debris flowing down, okay, into the downstream of the slope. This situation happen everywhere. This is in Japan. Um, if I'm not mistaken, this is in the Hiroshima, okay, where Hiroshima is one of the uh, interesting case study of landslide and debris flow, because it have repeated events, okay, and then causing loss of uh, loss of property, and also I am not sure that loss of life or not. Okay, but this is one of the case study that interesting. This is in Taiwan. Um, the debris flow occur. You can see the flow of the rock and debris. Okay, in this yellow boundary, slide down. Okay, all the building over there has been destroyed. If we look at this kind of landslide or debris flow, um, the basic mitigation to avoid the damage that would occur because of this is not to live there. First thing, you need to predict. You need to have some model, okay, and or you have to have some uh, information that this area has used to have debris flow before. Okay, by geological survey, you may be able to determine that this area has debris flow occur before or not, and then not to live there. But it's easier said than done. Basically, the house or the community already there, okay, since no time. Yeah? So that's why the second mitigation is, if we cannot move or prevent the house over there to be over there, we need to have a good warning system to evacuate people out, uh, just to be in time before the landslide or the debris flow comes. Okay, so these are the things that we need to consider. Look at the overview information of Thailand. Okay, we have both man-made and natural landslide. Okay, this is man-made in represent location in blue dots. Okay, and then red dots are the location where we have the debris flow. Okay, um, This is the mountainous area in Thailand, the northern part, the western part. This is the flat area. In the southern part, also this is the mountainous area. You can see that the blue dots or the man-made landslides occur everywhere. The color, the background color, is a representative of the rock type, okay, or geological rock type. Okay, you can see that no matter of what rock type, if you cut the slope, it has the potential of sliding. But for the natural landslide, it occur concentrate in some type of rock, okay, some area only where the monsoon or the storm is normally pass by. Okay, so that's why the landslide might occur in that area. Okay, let me discuss in some of the case history. Okay, that is had occurred and then is interesting enough to study in detail. The first case history is in the Philippines. You see the Cherry Hills landslide. Okay, you can see this. This is the mass of the slide soil, a rock over there. It happened in the 3rd of August 1999 because about heavy rainfall, because of heavy rainfall and then loss of life about 58. Actually, this used to be a mountain. Yeah, the mountain used to be bigger than this, and then they excavate the soil for the mining business and also for the soil for construction material. And then it may have left with the very steep slope. And this land became a very cheap land. Okay, that's people buy and then do the housing projects with the minimal cost. Okay, but the very high cost that they have to pay is the lie of their relatives or him or themselves. The rainfall occur very high. You can see the graph here. Okay, in the 29th of July and that year, and then after that in the 2nd of August, the rainfall shooting up. Only one day is almost 500 millimeter per day. That's very high. So causing the cut slope here to be unstable and slide down, okay, and then destroy all this house. Okay, so this case study, the lesson from this case study is whenever you have the cut slope, you need to remember that cut slope, that soil or rock, it seem to be very strong, yeah, very stable at the time after you cut. But remember that the rock or soil can be deteriorated by time. Okay, the rock became deteriorated to be soil. The soil can be eroded. Okay, and then causing the steeper slope, something like that. And then finally it will slide up. Okay, in this first case history. The second case is in US. This is the area called the La Cochita landslide. It's interesting because it's happened twice in 1999 and 2005. Okay, this is the first time and second time. And then you can see this. This is the area of the village or the housing over there. It's quite pleasant to live over there. I imagine because you have the ocean in front of you, you have the mountain on the back. Look very nice. Okay, but if you look at the slope topography, it seems to be scary. You can see maybe this is the old scarp of the movement or sliding. Okay, you have the big erosion. Okay, that the water flow through and then release to the ocean here, and then you have the case of the what we call the cutting down of the river, okay, through this kind of rock or ground. The first event occurred in 4th of March 1995. Second one is 10th of Jan 2005, caused by heavy rainfall and claim about 10 lives. Okay, let me show you the difference between two events in 1995 and 2005. You can look at the precipitation record. Okay, this is the precipitation record in 1995. Okay, there was a heavy rainfall. Okay, just about a month before. Okay, the landslide occurred. At the day of the landslide, you can see that the precipitation in that area is not that much. Seem to be very low as well. Yeah, comparing to the second event, you can see that the uh, the landslide occur at the day that the landslide occur, the precipitation was very high. Okay, comparing to previous days. Okay, and then it slide. So in conclusion, for the precipitation for the first case, there was a heavy rainfall before even though it's a month before the landslide occurred in 1995. So it seemed like heavy rainfall could accumulated into the ground, especially the area above, the village, housing project, housing area like this, in this, and it may be infiltrate down into the lower groundwater level and then slowly move, okay, and then try to release out at the slope. Even though 1 month later, but heavy mass of heavy rainfall that turn into the groundwater, okay, maybe flow out and then causing the failure. Instead, on the other hand, the second event, okay, like this, okay, in 2005, okay, uh, seemed that the heavy rainfall occur only one time and then sliding down, okay, because of the infiltration from the surface of the slope and then causing the saturation of the slope and then slide down. Okay, um, this is the cross section. Okay, this is the cross section showing that this is the old landslide, old slide debris. Okay, old slide debris, and then you can see that the estimated groundwater level, okay, from the 1995 landslide, groundwater level might increase, okay, and then causing the reduction of the shear strength, because when water increase, the soil will become soft, okay, especially the old slide debris, which maybe occurred 1,000 years ago, okay, and then accumulate in this surface when it's subjected to a pressure or water pressure from underground. Okay, it's caused the slide, okay, and it's going to be a deep slide and then progressive. Progressive means that if this one slide, okay, and then cause the unstable of this zone, and then the next zone will slide down, something like that. Okay, this is the mechanism for the 1995. Okay, okay, like this, you can see a big chunk of soil slide down. Okay, and in 2005, okay, heavy rainfall infiltrate. Okay, and then maybe groundwater table maybe not high, but because of the heavy rainfall infiltrate at the surface, it slide down, and then at the area where the water is discharged. Okay, if you look closely in this photo, you can see that this mass slide down. There might be a road over there. Okay, and then you can see that the debris seem to be divert or move to the right side of the photo. It's because of this. Because of this, the residential here, they build retaining wall like this, okay, in order to protect, okay, the debris to the house. But the debris divert, okay, and then destroy this house instead. Okay, and you can see the damage of the retaining wall over there. It did its job, okay, but anyway, it's divert the hazard to the other area. Let me take a break, okay, and then I will come back, okay, with this with this case study in Doi Chang in Chiang Rai province in Thailand. Okay, just take a break and then we go to the second clip, okay, of this lecture.